We'll be looking at question 16 from the 2014 revised higher physics paper. 5 resistors are connected as shown. Here we have a series of resistors. This branch is in parallel with this branch, which is in parallel with that branch. And it asks us to calculate the resistance between X and Y. So this is a fairly straightforward question, as long as you can do fractions, I suppose. I'm just going to redraw the circuit diagram very quickly. Effectively, we have one resistor in the middle, and we've got 2 at the top, like this, and we have 2 at the bottom as well. And I'm not doing a very good job of this, but that's the idea. The 2 at the top are 30 and 30, so that gives a total resistance at the top of 60 ohms. There's 60 in the middle, and there's 60 at the bottom. Now, the easiest way to add resistors in parallel is to use the formula 1 over RT. For total resistance is 1 over R1 plus 1 over R2 plus 1 over R3. And that would be 1 over 60 plus 1 over 60 plus 1 over 60. So 1 over RT is equal to 1 over 60 plus 1 over 60 plus 1 over 60. And that gives 3 over 60. Of course, that's not our correct answer. That's 1 over RT, so at this point I tend to flip everything over. So RT divided by 1, which is equal to RT, is just 60 divided by 3. So I've just flipped that, and I've flipped this, and 60 divided by 3 is 20 ohms. Now, of course, if you know anything about resistors in parallel, you'll know if they're the same size and there's multiple resistors, then you just take the value of 1 and divide it by the number of branches, and that's effectively what we've done here. So the answer is 20, which would mean that B is the correct answer.